Alright, so let's go through this trial of 12 where we have a ball is given a push to start it rolling freely up a slope. So the velocity time graph is as shown, which shows the change in velocity of the ball with time. So same thing, whenever we look at the graph, we look at the axis first. So one is velocity, one is time, right? Okay, so part A, state the time when the ball reaches the highest point on the slope. Okay, so let's take a look at what is going on for this ball. So first thing, right, when I push, I must give it a very high velocity. So you can see that, oh, my velocity is 15 meters per second at 0 second. So this ball at the start has a velocity of positive 15 meter per second. So of course, you slowly rise up, you will decrease in your velocity until you reach 0 meter per second. So at 0 meter per second, you're actually on top of the slope. So this is where time equal to 6 seconds. Your velocity is 0 meter per second. Okay, after that, we go to the negative region of the graph already. So negative region of the graph just means you are going in the opposite direction. So at the start, right, you're actually moving upwards. So means it's in a positive region. So after that, you go to the top, then you must of course go down, right? So when you go down, so for example, let's just say I draw here. So when you go down, you are moving in the opposite direction. So you must go to the negative region already. So you go down and slowly increase in speed, right? So at 8 seconds, you are negative 5 meter per second, then 10 seconds, you are negative 10 meter per second, so on and so forth. So that is how you interpret this velocity time graph. Okay, for part A, state the time, right, in which you will reach the highest point. For this type of question, very simple. As long as you see 0 meter per second, that is highly likely the time where you reach the maximum point already, right? So the answer will be 6 seconds. Okay, so part B, determine the acceleration of the ball at the highest point on the slope. So which is at the 6 seconds. So for this, just make sure that we know that acceleration at the highest is not equal to 0. Although you're not moving, but doesn't mean you're not accelerating. So how do I get the acceleration from this velocity time graph? Very simple. You just look at the gradient. You must calculate the gradient, right? So how do I calculate the gradient of this point of this line? So you just, because it's a straight line, so the gradient is the same everywhere. So you just need to calculate any part. So for example, let's just say I use this first part and the maximum point part. So you just need to use acceleration equal to final minus initial divided by time. So the final speed or the final velocity of this ball is actually 0 meter per second, right? Then after that, you minus the initial velocity. Then next, you divide by the time taken. So the time taken is roughly 6 seconds. So you can see that at the top right is roughly, let's see, okay, is negative 2.5 meter per second square. Alright, so it's not 10 meter, negative 10 meter per second square because this is a slope, not really up-down direction. Okay, so part C, determine the average speed of the ball between 2 and 12 seconds. Okay, so just take note for average speed, you must know the formula. So average speed is total distance divided by total time. So what is the total distance traveled between 2 and 12 seconds? Let's calculate. So, okay, from velocity time graph, how do we know what is the distance? You look at the area under the graph. So from 2 to 12, right? So 2 is right here, then 12 is right here. Right? Okay, so you can see that there are roughly 2 triangles. So the very first triangle, you just need to calculate. So half times base, okay, so base is 6 minus 2, 4 times height, right? So height is 10, so it's roughly 20 meter. Then for this negative region, you just take the so-called magnitude. Because distance there's no negative. So okay, half times base, same thing, half base is 6, then height is 15. Okay, so let's do our calculation. Okay, so it's roughly 45 meter. So the total distance traveled, right, between 2 to 12 seconds is actually 20 plus 45. So 20 plus 45 is 65 meter. So okay, so let's write down. So it's equal to 65 meter divide by 10 second. So it's roughly 6.5 meter per second. So that is the answer for this average speed. Okay, so what if I change the question a bit? Instead of finding the average speed, I want to calculate what is the average velocity. So average, okay, let me just write here. So average velocity. Okay, so just remember there's a minor, or I would say there's a very big difference between average speed and average velocity. So for average velocity, it's the total displacement divided by total time. So time, of course, the total time is still 10 seconds. From 2 to 12 seconds is 10 seconds. Okay, what about the total displacement? Okay, total displacement, we go back to this graph. We cannot ignore the negative in the negative area already. So for example, between 2 to 6 seconds, we know that, my total displacement is positive 20 meter. Then next, you look at the negative region, the negative triangle, right? We cannot just put 45, we must put negative 45. So something like negative area like that. So negative 45, right? So the total displacement is, okay, let me write here. Okay, so the total displacement is 20 meter plus negative 45 meter. So it's actually equal to negative 25 meter divided by 10 seconds. So you will get roughly negative 2.5 meter per second. So that is how you calculate the average velocity if you are being asked this question. Okay, so now let's move on to the last part of the question where we need to sketch a displacement time graph between 0 to 12. Okay, so for velocity time, so for example, let's just say I sketch the velocity time at the side. Okay, so velocity time is like a downward sloping like that, right? So at the start is 15 meter per second, then 0, then next will be negative 15 meter per second. How do I translate velocity to your displacement time? Okay, so for Sec 4s, you will learn something called the integration. So integration, which I think we'll not talk about this first. So you just have to memorize that. Okay, for this first part, straight line, right? When you translate to displacement, you will need to become a curve. So curve, and what type of curve you need to sketch is like something like this. So it's like this. Okay, so you will sketch from this to this. Okay, so that is, okay, at this particular point, right, this is where you will reach the maximum point of your slope. Then after that, because you're going down, you're going downwards, right? So it means that 12 seconds, you will go back to your original position. So there shouldn't be any displacement for the ball. Okay, all right, so that is all for this question.